MTR Academy, and project and product delivery, as well as R&D commercialization. For railway engineering solutions provider, Dr. Mark Hall was awarded the bachelor and PhD degrees at the University of Birmingham, both on electronics and electrical engineering. He is a chartered engineer, a chartered professional engineer, a fellow of Engineers Australia, a member of the IET, and Institution of Railway Signal Engineer. Without further ado, I give you Dr. Mark Hall.
Right, thank you. Hello. Hello, can you hear me?
Yes,
Hello.
yes, loud and clear.
Right, great. First of all, well, thank you very much, Dr. Wong, for your introductions. It has been a pleasure to meet you all. Good morning, everyone. It's a pity that I can't be with you in person because of all the travel restrictions and lockdowns and everything. But I try to play it to my advantage, because if you don't like the talk at the end, you won't be able to throw tomatoes or eggs at me. So I try to put it to my advantage. Now, let me just share the screen for you. Now here it is me, I think. Right, okay. So as Dr. Wong introductions earlier, I have been fortunate enough to be involved in the railway industry for, well, in various capacities. In the first 20 years or so, I work in universities. So I oversaw curriculum developments for engineers, and also conducting consultancy services for the railway industry. And then in the last 10 years or so, I spent some time with the industry, with the operator, with the SS owner, and as consultants. And in the past 4 or 5 years, I have been involved in the consultancy work particularly in Malaysia and Kuala Lumpur. And there has been a quite substantial amount of railway work in Malaysia. But one of the challenges that we come across is that we can't find a good number of young railway engineers in Malaysia. Well, even though we come from Hong Kong and the government invites us to provide service, but I think most of the work should be done by locals. And the knowledge transfer to the locals is an important part of the consultancy work. But unfortunately, in the last few years, we don't find enough people showing interest to the industry. And well, perhaps one of the reasons is that people would think it is a rather old industry and nothing exciting in it. So that's why that is one of the motivations of having this talk. And I hope I can use some of our experience to share with you what's actually inside the industry, and how what you are studying would be able to contribute to that industry. And as Dr. Wong said, there hasn't been too many undergraduate programs, specifically for railway engineer or railway engineering. I can only see 1 or 2 programs in UK, and of course in China there are quite a number of undergraduate programs for railway. But don't forget, in China the situation is very different. Some of the universities were previously owned or operated by the Ministry of Railway. And China is a big country. They have a lot of railway to develop. So for them to have a few universities working specifically for railway doesn't come as a surprise. But for other places, even in UK and Australia, you can't find too many undergraduate programs. Postgraduate program, yes, a few, but not a lot. But don't be scared by such a overview or the current landscape, because what you have been studying, whether it is engineering related or even non-engineering, you will find a way to contribute to this particular industry. So in the talk, what I would like to do is I'll give you a brief history. Well, did we say that railway is an old industry? So it must have a long history. And then we will try to look at the key elements in the railway service provisions, and particularly how they fit what you are studying. And then we'll go through some of the career opportunities, some of the positions that you may be interested in. Oops. Now, did we say railway is an old industry? Perhaps yes. Well, it has a long history of even a few thousand years. But before that, let's look at, oops. Let's look at some definitions. Well, we are now studying in university, so we look at everything from definitions. So nowadays, if you want to look at some interesting definitions, we go for WikiCheck, Wikipedia's, or in Chinese, Baidu. So that's what I found out. For railway transport, really the basic definition is you have some wheeled vehicles running on the track. Then there you go. You will have it. And in Chinese, it's very much the same thing. So let's look at, oops, some of the early railways. Well, by early railways, I'm talking about 2,000 years ago. So I actually did some search on the internet. It is the oldest I can find. It is about 2,000 years ago, somewhere along Greece. And there are 2 ponds over here, people trying to build some paved trackway to move goods over a distance of something like 8 to 9 kilometers. The idea is that at either end of what we call the railway here, or the track here, are the 2 ports. So instead of moving people or goods between these 2 points by ships, then that you have to go through a long way. So that is a shortcut if you are able to move things quickly. So that's the original idea of having a railway. But of course, it is not exactly the railway that we see to date. So what's come next? Well, in the following, well, something like 1,800 years, there has been some development. Still the same thing, we have wheels running on tracks. So you can see we have cart on wooden wheels, running on wooden wheel. Remember, in those days, we don't have the metallurgy's technology is not very advanced. So people do not use metals that often, or the quality of the metals are not very good. And so wood is the latest technologies. That's how it works. And another significant thing is the power only coming from men or animals. Well, we don't have engine, motor at those times, but people still recognize moving things on wheeled vehicles would be a good idea. And on the right-hand side, probably you will see that some vehicle moving uphill. It's kind of a horizontal railway, or you can call it a lift. And that's what it is. That's how people move things along. So railway, in some sense, it's not just horizontal, it's not just to facilitate movement horizontally, but sometimes vertically. So in some way, you may argue escalator or lift are one form of railway. Then we fast forward to 18th, 19th century. we have the industrial revolution. So people start coming up with steam engine. So that's how it looked like. Remember, at the time, it was the latest technologies, and people were just looking at it just like we're looking at the latest iPhone. So that's the latest technologies providing us with the means to move from one point to another. But of course, if you look at the timing, the first steam engine is at 1775, but the first commercial steam engines come in something around 50 years later. So things move rather slowly in today's standard at those times. So that's how it is. Well, they didn't have internet and all other things in the old days. So that's why things move rather slowly. And things move on a little bit. Well, since we have the steam engine, and so with certain improvement in the technologies, we have the steam locomotive. So that really come into the breakthrough that we can make use of the technologies to provide full public railway service. So that's how those things look like. And well, here I just list the time at which a number of countries actually start the public railway. So basically, in the mid-19th century, a lot of Western countries, they have the first railway line running. And well, there are certain significance in those timing. For example, if you look at US, well, probably you still remember when actually US starts is around 1776. So at the very beginning, US is a very much an undeveloped country, and all the immigrants actually start at the eastern part of US, that is around New York, Boston, and they start moving to the western part of the country in the mid-19th century. And railway is one of the key vehicles to move all the business and all the operations from the eastern side to the western side. And you can argue that railway is actually the key for US to develop itself by the end of 19th century, one of the strongest or biggest economies in the world. So you can see how railway actually help the societies. And for China, this first railway line is actually started in 1876. Wushong railway, but unfortunately, it was only in operations for a couple of years before it actually shut down, and it won't start again until the early 20th century. Now, soon after the steam engines, here come the diesel locomotive. We have the diesel internal combustion engines, started in the very late 19th century. So the first locomotive, 1912, and by the end of the 60s of the last century, really all the locomotive, well, really, we don't have steam engines anymore. They are now for show. All the locomotive was replaced by diesel locomotive, and later on, of course, by electricity. And you can think about as an engineer, you have to think about the advantages and limitations. For diesel engines, of course, it is a bit, the operation is simpler. You don't have to put all the coals into a big boiler to heat up the water, to make the steam, and then use the steam to push the engine. You just start the engine, and just like you start a car now, and it just easy to go. And as far as safety is concerned, it's also improved a lot. But later on, we will also think about the advantages and the limitations, the comparisons with electricity or electrifications in railway. And of course, The next step is the electrifications. Well, because we have electricities in the early 19th century, so people would start thinking about how about using electric motor. So the first electrical motor in Scotland, driven by battery. So it's just like all the fun car that we will use in theme park nowadays, but of course it's quite different. And by around 1879, you have the first passenger trains in Berlin. And indeed, from the at London Underground, the first electric line was first up and running in 1890. But there was an interesting story in it. I don't know whether you are aware that London Underground, perhaps the oldest underground railway service in the world, it actually started in 1863. So note the timing. There is a time difference between 1863 and 1890. So if London Underground has the first electric operations in 1890, so what happens when they first started? Think about it. At the very beginning, they have steam engines in the 1863. But imagine yourself, or putting yourself into the train underground within the tunnel with a steam engine train. It's smoky, it's not comfortable with all the smoke and coal burning in the same tunnel. So that's one of the main reasons why people actually change to electrifications, particularly for underground line in the early day. And of course, even in US, by the end of the 19th century, they have the first electric operations for railway. And things move on with a electrified railway. So at the early 20th centuries, particularly over Europe, if they are not using diesel engines, they would be putting electrifications on. And literally by mid-20th centuries, all metro operations has been on electricities. And of course, with electricities, and then lately in the last 20 years or so, all the high-speed railway services would be operated on electricities. Now, as engineers, perhaps you can think about what would be the advantages of using electricity for railway. Is it an overwhelming advantage? Well, as engineer, we have to think about advantages and limitations when we should be aware of the fact that no engineering system is perfect. So as engineer, it is our responsibility to think about advantages and limitations. Well, I'm sure you will argue that by using electricity, apparently pollution would not be a problem. A yes and a no. It depends on how your electricity comes about. If it is by burning coal, you still have air pollutions. You just shift the locations of pollutions from one place to another. If the energy source is from renewable energy, yes, your argument is valid. Okay? And then you think about the operations. If you are on diesel engines, that means each train is carrying its own fuel. So if one train breaks down, other trains will be are still able to move around. But with electricity, all the trains, they don't carry their own fuels. If the power supply system breaks down, then the whole thing breaks down. Okay, so you will see you will see it from the angle of operation. It's not just on the train. You have to see, well, if well, the train is running perfectly okay, but if the power supply system is not going well, then you won't have the service. So that's the limitation of electricity. Okay, so my point is you try to think about advantages, limitations, no matter what position you are in. Right. So in the last few slides, I just very quickly looking through the railway technologies. Of course, it has been advancing with time, but is railway development also advancing forward together with the technologies? Now, let's see. In the last few slides, we go through the technology, particularly from the beginning of 19th centuries up to now, or up till the beginning of 20th century to start with. The technology has moved pretty quickly from steam engine, diesel engines to electrifications. So you would expect the same trend would continue. But unfortunately, particularly after World War II, the development actually come to a rather slow progress. And of course, after the World War II, the populations expand. So the road and air transport will take over, particularly for short, well, even for short and long distance travels. And one another main reason is that railway was largely government owned or operated. So it becomes a service, but no government is looking for a profit. So basically, it's just a community service to move people or goods from one place to another. As long as you get onto it, you don't, well, they don't care. Well, it has to be affordable, and therefore it is not profit seeking. So in a way, so the government wouldn't look at the quality of the service. As long as I can move you from one point to another, that's it. I have done my duty. So you just get on the train. So if you look at some of the photos that I take at the bottom of the slide, the safety will become a problem, and the overall environment at the stations, at the train compartment, all those photos were taken in the 70s. So you can look at the service that you can get by those time. So that's how it was in the 70s. But of course, the railway actually enjoyed a revival in, well, starting in the 80s. The energy crisis in the 70s, of course, put pressures on road and air transport because the fuel price has gone up quite a bit. And another thing is, and another reason is, a lot of countries or cities around the world, they have expanding populations. So they have to locate the people. So one way of doing it is to expand the city, to make it bigger. Then you have to convince people to move further away from the CBD areas. Well, it would be cheaper, but you have to also convince people that the transportation would not take you too much time. We will build a metro line to connect you from well, even 20, 40K from the CBD. Every morning, you just need half an hour or 45 minutes on a train, then you can come to the CBD to work. So that sort of thinking actually put railway back onto the map. Another thing is the idea of customer-oriented service. That means the service is more than just moving people or goods from one point to another. It was the case in the 70s or 80s, but not anymore. Well, I'll give you two examples. I still recall 40 years ago when Hong Kong had its first underground metro system. On the first day of operations, I still recall on the telly, one reporter actually asked, well, just pick one of the guys on the street and say, "Well, why are you so keen to get on the new metros? How do you like it?" And the guy just answered very simply, because of because the metros here is air conditioned. Simple as that. Well, remember 40 years ago, nothing is air conditioned as far as transportation is concerned. But in those days, having air conditioning is one advantage. But of course, another example is that nowadays, air conditioning wouldn't get you onto a railway. It has to be, well, you would ask for more. It has to be comfortable. It has to be reliable. It has to be punctual. And please, Wi-Fi. Probably that's what you would ask for these days. So the customer-oriented service, the expectations will change with time. Perhaps later on, I don't know, you would ask for 5G on the railway. Otherwise, you won't go on board of a train. So let's see. But what I'm trying to get to is now railway is being as a tool to grow economy and to facilitate population distributions or redistributions. And with all the new funding going into the railway industry, now that you can see quite a lot of new system coming around, and the environment in the stations on the train are very different. People would expect something very modern looking. They don't want to see the good old railways, very rundown, torn out environment anymore. Right. Then, well, let's I'll look at railway service provisions and what actually contributes to the railway service provisions, particularly from the angle of where you are. You are now studying engineering or other things, and then you will say, well, how does it relate to railway service? Well, there are two main aspects or area. One is engineering, and other is operations. Well, engineering is very straightforward. In a railway system, you have quite a number of large-scale engineering systems putting together, working together. So you need engineers to work with them. But another part is operations. That is how to run the lines, how to run the stations, how to run the trains, how to coordinate the timetables, how to coordinate the service and people, how to deal with incidents. If something happens, somewhere catch fires, for example. So what are we going to do to make sure that the overall operation is safe, reliable, and available? And to give you a good idea, in Hong Kong, there's only one railway operators. They have something around 18,000 employees. And indeed, more than half of them are on operations. Okay, so they are probably not on engineering background, but we need all these people to get the system up and running. Right, let's start talking about engineering. As I said, there are quite a number of large-scale engineering systems in railway. Well, obviously, when we're talking about railway, one of the engineering systems that you can think of is the train. But in railway professionals' terms, we don't call it train, we call it rolling stock. Well, if you ask me any reason why, I would say, well, because by calling it differently, make it look more professional. Well, that's how it goes with any other professionals. We try to create some terms that no one else can understand, but well, for us, it's just rolling stock. Yeah, that's the train. So that's how it goes. Okay, if you look at the trains, well, probably it is the interface with the passengers. And therefore, you may notice quite a number of subsystems on board of a train. Well, I just try to list them all out to start with. Yeah, just about it. So For the train, of course, for us, we only look at the train body. Well, to make sure that the train body would be light enough to carry, but at least they would be highly resistant upon impact for safety reasons. But inside the train, or even outside the train body, you have quite a number of different subsystems, if you like. You have the power collections device so that you can collect, well, assuming electrifications, you have the pantograph to collect the power from the overhead cables. For example, you have air conditioning. Nowadays, of course, you expect air conditionings, well, particularly in Malaysia or places like Hong Kong. You can't go without air conditioning nowadays. And you have train doors. You have traction motor, the motor that will get the power, electrical power, and convert it into train movements. You have passenger information systems to tell you what the next stations would be. And in some cases, you may have entertainment systems to show you the news and the football score from last night matches in Europe. You have the train cab control to receive the signaling informations. So a lot of things coming together on board of a train. So if you're looking at what sort of engineering work that has to be done, I would say for rolling stock, it is mainly the mechanical engineer's territory, because the main part would be the train body. That would be the mechanical engineers. But then you have the passenger information system, you have the air conditionings. So you have electrical, electronic engineers coming into it. You have informations, IT engineers coming into it. So it's a combination of different disciplines coming together. Well, another important subsystem would be the signaling. Well, the signaling would maintain safety, that is the safe separations between two trains. And it also allows as many trains running on the line as possible without jeopardizing safety. And of course, nowadays, signalings are very much on automations. So you don't rely on a signalman standing next to the railway line to indicate red or green, stop and proceed, and all other things. So for signaling to move, to operate smoothly, electronic engineers, communication engineers, computing engineers, they are all required to make sure that signaling will be in good order. Well, another main systems or main engineering system, obviously, would be the track. Well, railway, you have to have the rail. For the track, in terms of structure, it is much simpler because you just put two metal rail on top of the ground, and then you make sure that they are secure. And if you look at all those small stone chips, they are called ballasts. And then you have the slippers. So depending on where the tracks are, whether it is outdoor, in a tunnel, you would have different combinations of ballasts and slippers. They are very straightforward, apparently, but obviously it is for the civil engineers. And because, wherever the train will go, there must be track. And then all the civil work, well, even though they look simple, but I can assure all the civil engineers that's sitting around, in any railway project, the civil engineers will take around 70% of the budget because of the material, because of the labor work, etc. So the E&M, or electrical and mechanical engineer, will take the other 30%. But don't forget, for the electrical and mechanical guys, don't be disappointed, because once the track is built, they are there. Yes, you have to do quite a bit of maintenance work, but you don't need to be there all the time. But for electrical and mechanical engineers, even after upon the constructions of a railway, you are still required to be around all the time to keep the smooth operations of the railway. Okay. Now for electrifications, of course, you need power supply. As I said earlier, the reliability of the power supply system is very important. If anything wrong with the power supply system, no train would be able to move. Okay, so basically, the electrical engineers are required to ensure that the power supply system throughout the whole lines would be up and running at all time. It is not an easy task. Remember, for example, if you look at the photos on the left-hand side, you have a lot of equipment alongside the railway, and if it is on outdoor, a lot of factors can come in. You may have lightning striking down one or two of the facilities. You may have people, animal running across the railway. That will create problems. So it is not an easy task to maintain a safe and reliable power supply systems, let alone the technical side. But there are other factors to consider. So all in all, we have talked about the four main systems so far. That's the rolling stock, signaling, the track, and power supply. And all these actually get civil engineers, mechanical engineers, electrical engineers, electronics engineers, and all other disciplines like IT, computing, etc. So a lot of what engineering disciplines of all sorts would be required to get the railway operations up and running. And another idea that I would like to put into your head is system integrations. Well, I have talked about the four main disciplines, the rolling stock, signaling, power supply, and track. But on their own, they may be working pretty well. But if you put everything together, can you assure that it worked together? That's the main thing. That's what system integration is all about. So by system, that means we have a big system having a number of components, hardware and software connecting together. And the integration is to how to get them work together. Well, railway is one good example of big systems, but surely you would have other systems on your hand, like your mobile phone, your laptop computer. They consist of a number of different components. For example, your mobile phone, you have a screen, keypad, battery, a CPU, camera. On their own, they would work perfectly. But now you have to pack them into a small package, and you have to make sure that it works together. So it is what system integration is all about. So it will apply to your mobile phone, it would apply to a car. So if you think about the same concept in railway, that means even if you are, for example, a mechanical engineer, your main concern would be the train, the car body, but you have to understand a little bit of power supply. You have to understand a little bit on signaling so that you can work with the other side, so that you can change or adjust your design of your train to meet the requirement of other systems, because you have to work with them. Now, a complex systems, I just give you the idea, complex systems can be decomposed into a number of subsystems. So in the case of railways, the big railway system can be broken down into rolling stock, power supply, signaling, etc. And of course, by combining all these smaller components, subsystem together, that would be the integrations. So now system integration is always asking the questions that, well, you have subsystem A, B, C, or D, or whatever. They all work perfectly on their own. But if you put two systems together, would they work? So that's the purpose of system integrations. We have come to a number of situations on which we have trains running freely on its own on the line and on testing. It perfectly okay. It can move from one end to another. And then we try to test the signaling systems and it work on its own. But when we try to put the train running on signaling system, that means signaling will control the train movement so that it won't bump into another train. But once we put them together, it didn't work at all. It happens. So that's what, and that's how system integration is important these days. And if we look at some examples of, well, even though, well, don't take them as a joke, it happens. Well, these are the simple examples of lack of system integration. It happened in our life, and quite a few as such. And I mean, I can take those photos because it actually happens. And it is an extreme case of lack of system integrations. And for railway, as I said, we can start from the railway systems. We can have a number of subsystems and so on. And the idea of putting all the subsystems and components together, that is system integrations. So the idea, the point that I'm trying to convey is that in addition to the conventional engineering disciplines in mechanical, electrical, civil, we're also looking into another disciplines called system engineering. That means we have to look at what we are doing from a system perspective. If my system is going to interface with another systems, how should I prepare myself? How should I design my system so that it would be compatible with the other systems? And how can I make sure that the other party is doing the same thing? Okay, so it's more than just technical discussions. You have to talk to the engineers. Well, in railway, it's not uncommon that the civil engineers, they don't talk to the mechanical guys. They said, well, we are the best, so we don't have to talk to you. And the mechanical guys would think in the same way. It's very common, and I don't blame you because I'm an engineer, so I understand the mentality. And of course, the major subsystems in railway, they all have interface with each other. For example, the rolling stock, well, permanent way is just the track. And again, we call it P-way just to show people that we look like professionals. But permanent way or P-ways is actually the track. So the train and the track would have the interface through the wheel and the wheel. Okay, so and that's why I said the civil engineer and the civil engineer who look after the track and the mechanical engineers who look after the rolling stock, if they don't talk to each other, they will be in trouble. I'll give you a very simple example. Well, even though the interface between the two subsystems are the wheel and the wheel, but they have a lot of argument. Well, I presume your perceptions of a wheel must be round. Well, a wheel must be round, a circle. The standard size of a railway wheel would be 750 millimeters in diameter, okay? But think about it, it is a very heavy metallic parts. So after a few years of operations, the wheel may not be a perfect round object anymore, okay? Because of the weight pressing on it. So it will becomes slightly elliptical. Well, when I say slightly, the measurements in railway is how we call it out of roundedness. The out of roundedness is being measured by the diameter. Well, as I said, a perfect wheel would be 750 millimeters. So if the out of roundedness is plus or minus 1 millimeter, okay? So a perfect circle will become an ellipse, okay? A slight ellipse. But if such a shape is actually rolling on the wheel in high speed, it will cause damage to the wheel, okay? So the mechanical engineers and the civil engineer would be pointing finger to each other. Well, it is your train actually damaging my track. And the civil engineer will say, well, and the mechanical engineer will say, well, it is your track, which is not perfect, that actually damaged my wheel. So the arguments always goes on. So the point of having system integration is the communications and understanding across different disciplines. So my point to all the young engineer sitting in this webinar is that even though you are studying one particular discipline, be it electrical or mechanical, don't be afraid to try to understand other disciplines. It will help you. I mean, not only in railway, but in other industry as well. Right, let's move on. And of course, in railway, you have other systems like the railway telecommunication systems. The communication systems will enable you to do a public address, passenger informations, and a lot of things. So that will get the communication engineers and electronics engineers into play as well. Are they all in terms of subsystems in railway systems? Not quite. We also have stations. In stations, you have a lot of facilities, a lot of service provisions that you would have to look after as an engineer. Well, you have platform screen door, you have automatic fare collection gate, a lot of other things. They are electronics systems, they are mechanical systems. The door, the platform screen door would be mechanical systems. The public announcement system would be communications. So a lot of other things coming together as well. And the worst bit is you have a lot of people. There are certain uncertainties coming along with people. So you have train operator, controller, station assistants, and worst of all, it's the passengers. You have all kinds of people coming in and out of stations, and you have to manage them. So a lot of stakeholder, a lot of system coming into the overall operations of railway systems. And the next things I would like to talk about is system assurance, which is very much related to system integrations. And the reason why I highlight system assurance is that system assurance is the most sought after positions in railway industry, if you believe it or not. System assurance is highly related to system integrations. And system assurance is like auditing in accounting, okay? So a system assurance engineer is basically a technical auditor. Let's see what they do. Now I better get everything out. Well, for railway system construction or development, from the very beginning, when you have nothing, and up till the end, you have operations and maintenance, there are a number of steps. And throughout all these steps, it will take quite a few years. Well, for a metro system, typically 3 or 4 years. For a intercities railway lines, it could well be 10 years. And when people talking about the Malaysia high-speed rail, you would be talking about 8 to 10 years to get the whole lines up and running. So throughout the process, you have a number of steps to go through, and you have a number of stakeholders. So for the railway operator to build a railway, of course, at the end, the passenger will pay the fare. And the railway operator have to appoint a number of contractors to build the railway in different for different subsystems, like the rolling stock, track, and all other things. And then the operator will also hire a number of consultants to advise them on how to build it, how to write down the specifications. And then the government will come up with the regulators to look at how things goes all along, how the public money or money from different sources has been used, and whether the safety has been observed in the operations, etc. And of course, there are a number of contractors working for the operators. So a number of stakeholders coming around, going through a process from nothing to the overall operations and maintenance of the systems over a period of 5 or 6 years. So can we be sure that everyone working in the same directions, working according to the specifications? So we have a number of subsystems, and each subsystem will have a number of contractors, consultants. So that's the landscape of the railway system development. So at the end product has to come through the integrations process. And the system assurance guide is to make sure that all parties, all stakeholders are doing exactly what they are supposed to do. And what they produce are compatible with what other parties has produced, so that they can be integrated together. So basically, the system assurance engineers is to work with all stakeholders to make sure that the end product can be put together, can be integrated together, and the ultimate railway system would be able to run as expected. So the railway system life cycle, that's the design phase, construction phase, and system assurance people has to go through all these phases together with all the stakeholders. And the basic idea for system assurance, particularly for railway, is to make sure that the projects are being designed, built, tested, and commissioned to meet the requirements on reliability, availability, maintainability, and safety. And there's an international standard for all these. And here, I would like to highlight the 4 keywords: reliability, availability, maintainability, and safety. What do they mean to you as a customer? What's the difference between reliability and availability to you? Well, reliability from the passenger perspective, what it really means is, if for me, when I get on a train from home to office, if it takes 20 minutes today, I would expect it to take exactly 20 minutes tomorrow for me to go from my home to office. It will be the same the day after tomorrow, and so on. That's reliability. Every time I use it, I will get the same service. That's reliability. Availability is whether the service is made available to me. So reliability and availability are 2 different things. It may be very reliable, but the availability may not be very high. That means, well, today I take 20 minutes to go from my home to office. Tomorrow, the service is not available. Even though the day after tomorrow, the service resume, and it will take exactly the same 20 minutes to get me from home to office. It is reliable. Every time I use it, it takes 20 minutes, but it is not always available. So they are two different things, okay? So high reliability, that means every time I use it, I expect to have the same service. And high availability, that means most of the time I want to use it, I can use it. So that's availability. Maintainability is talking about, of course, the maintenance. Is on how exact or precise that the engineer can specify how long the maintenance work will take. So if I put one train back to the depot for maintenance, for this type of maintenance work, I would say it will only take 1 day. And every time the train comes to the depots to do the same maintenance work, it is always 1 day. It's not that, well, for this train, I have to use 3 days. For that train, I have to use 4 days. So that is not very good maintainability, because maintainability is also related to availability. If the engineer or the operators can be very certain that how long a train has to be out of service, then it would put certain confidence into the availability of the service. Well, the last thing, safety, which is the most difficult bit, okay? Of course, we all know what safety is all about, but how safe is safe enough? Can we measure it? And for the other three things, the reliability, availability, and maintainability, we can design the system in such a way that even before the operations, we know how reliable it is. We know how available it is. But for safety, we can only design it as safe as possible. We don't know how safe it will be until we actually have some time in operations, okay? For example, 1 year in operations, how many incidents, how many casualties, then we know how safe it is. But before the operation, we can only design the systems to as safe as possible, okay? And it's difficult to measure. And if you ask the passengers, well, the expectation could well be no accidents, no incidents at all. But of course, as engineer, we know that it is not possible. But safety is the most difficult part of the requirements in safety assurance. And in most of the time, any railway operators has to produce a safety case for the government to approve before a railway system is being allowed to operate. A safety case is to list a table, if you like, of risk management. So what sort of risks that the system would have? Well, all transportation would have a certain level of risk. I mean, no matter how good your safety measures are, there's always still a risk. Even though the risk would be as small as 1 in a million or even more, but there is always a risk. And the operator has to come up with a safety case to list all the possible risks and the means to mitigate all those risks. So that's the job for the system assurance, that's the job for the system assurance engineers. And that's very important. And for system assurance, well, if you are interested in the job as a system assurance engineer, first of all, well, I mean, there's no undergraduate program to train you as a system assurance engineer. You can come, well, you may come from any engineering disciplines, but the most important attribute is whether you have the interest to go into go into other disciplines, to have a good understanding of what other disciplines are doing, particularly in the under the heading of railway. And of course, you should have a good communication skill, and you should have a good attention to details. Then you would be able to be a very good system assurance engineers. And as I said earlier, system assurance engineers is a good system assurance engineers are very difficult to find. if you are interested in it and you get a few years of experience in railway system assurance, you don't have to worry about the rest of your career to find a good job. Right, these are the objective of system assurance. And I better quicken up a little bit. Well, another part of the railway provisions is the operations. And as I said earlier, operation is something more than just technical and engineering. In the railway industry, there are three main areas in operations. Well, we call it operating. One is the stations. That is the station, the overall station management. Once the passenger get into the stations, that means they start having the service from the railway, not from the moment that they bought on the train, but once they get into these stations, they are your responsibility. So at the stations, you have to make sure that the people within the stations are safe and comfortable, and you have to make sure that all the station facility are in good order. And particularly in very congested, busy stations, you have to make sure that there's a smooth passenger flow. And in case of any incidents, you have to make sure that all the emergency exit drill would be undertaken in good order. And then another part of the operating is the train crew operations. In the old days, you may call them train driver, train captain, but nowadays most of the trains, particularly metros, are on automatic train control. And so the train crew, we will call them attendants. But as passengers, you really want to have someone on the train rather than driverless trains nowadays. So the train crew would be able to perform train driving if the automatic system is not working. And they have to handle the incidents. For example, again, when someone gets sick on board of a train, and a few years ago in Hong Kong, someone actually set fire in one of the train, and then the train crew has to do something to deal with the situations, to comfort the passengers, to make sure that all passengers would be able to get out of the train safely, etc. And another part is the operation control center. So if you look at all the photos down there, it gives you a feeling that you are working for LASA, in which you have all the big screens coming up in front of you. And you are in charge of the overall operations. And I deliberately put it as a 24/7, 365 operation base. You may ask me the questions that, is it really 24 hours? The train service actually starts in early morning and it will end late in the evening. So it's not exactly 24 hours operation, does it? But don't forget, on those non-service hours, a lot of maintenance work are going on. So a lot of maintenance vehicles and personnel are working alongside the track. So the OCC, the Operation Control Center, has to make sure that all the work has been done safely. Okay, so all the monitor, all the communications have to make sure that even in the non-service hour, all the engineering vehicles, engineers, technicians working alongside the track would be in a safe positions to conduct their work. And of course, for operations, you always have the maintenance guy. In the railway terms, we have first line, second line, third line maintenance. The first line is performing or undertaking corrective maintenance. That means when something has gone wrong, something is not working, then we put on the repair work. That is corrective maintenance. Preventive maintenance is that before it actually fails, we put some work into it to stop it from failing. And it is important for railway industry because we don't want the train to stop suddenly on the track during service hour. So before anything goes wrong, we try to prevent it from happening. So that's what preventive maintenance is all about. Well, the third line of maintenance is to get the, for example, to get the trains to the depots or the workshop, and we disassembles everything from the trains and clean it and oil it and do all the necessary work before we put it back together. So that would be the major overhaul of the systems. And of course, in terms of operations, there are other supporting and administrative units. Well, I don't go into detail with it, given the time. Of course, we have human resources to look after all the member of staff. As I said, for example, in Hong Kong, even for such a small place, the railway operator actually hire 18,000 employees in Hong Kong. And indeed, the Hong Kong MTL actually have another 17,000 employees outside Hong Kong in different places. So the human resources people will be very busy in getting all these employees organized. And of course, we also have legal and governance. For the railway operator, they have to deal with the governments, they have to deal with the public, they have to deal with the lawmaker. So a lot of people will be working in those areas. So even if you are studying law at the moment, there's still also a place for you in the railway industry. And then projects. When a railway operator is asked, for example, to extend a line, that means they have to start a new project. Then you have to get system engineers, electrical engineers, mechanical engineers together to form a team to come up with a proposal, the engineering design. And then you have to look at the commercial contracts with the consultants and contractors and a lot of things. And you also have to go into the community and see whether the location of the stations, for example, would be good enough for the local community, etc. And then the environmental impact analysis and a lot of things to go on. And marketing, well, the Hong Kong MTR is doing pretty well with their marketing and a lot of souvenir and communications with the society. Corporate relationships, internal, external. My experience is that for the operators, one of the difficult party to deal with is the staff unions. And I think in different places, they have different difficult components in their portfolios. And there are a lot of others. So as far as operation is concerned, as I said, they still require a lot of people to work and contribute in the industry. So it's not just the technical people, but other people with a legal background, business, management, operations background would be welcomed. Now, let me take a few more minutes onto the career opportunities. In Malaysia, well, if my information is correct, the first railway line actually started very early in the late 19th century. But then afterwards, the development was rather slow. And I can understand the railway is, in the old time, is very much the British things. The British are very good in railway development. So they move their technologies to Malaysia, Singapore, Hong Kong, and a lot of other places. But in the 20th century, not until we get to the 90s, when the KTMB commuter train actually start their service, that the railway development in Malaysia has been very slow. But of course, in the last 10 years or so, well, you guys have a lot of developments in the KTM East Coast, ERL, light rail, monorail, the MRT now you have, well, line 2 is almost ready, line 3 is on the way. And I understand the high-speed rail is back on the map again. And so I understand they would like to have the first service from 2026. So a lot of new projects coming up. And I understand from the government that there is a huge shortage of professionals, railway professionals, in the next 10 years or so. And so the question is, are you guys ready for all these opportunities? And well, that's the map in Malaysia. I'm sure you guys are more than familiar with than I am. Well, what I would like to paint you a picture is a landscape of the railway industry and where the job opportunity or career opportunities will come from. And well, of course, the biggest employer, if you like, would be the operators. So in your case, it could well be Pasawana. And they would be looking after the engineering, design, the maintenance work, and basically providing the passengers and freight services. So they have to run the trains, they have to get the income from the passengers or customers. And other source of employee or employer, sorry, is the government. Because railway is a big industry and it also provides service to the public at large. So the safety and it is one of the key parameters in the operations. And of course, the railway development has to go along with the policy, the transportation policy throughout the country, or in particular, certain cities in questions. So it has to go along with the urban planning. When you have to build a line from one point to another, what are the policy on building the houses or offices or other infrastructures alongside with the railway? That would be the urban planning. That's come from the government. And then the consultants. And the consultant always looking into the engineering design, producing the system specifications, the subsystems specifications, how to integrate the systems, how to conduct the commissionings and testings, and usually they will also manage the projects for the railway operators or SS owner. Another major employer would be the contractor. Well, they are actually doing the work. They are the parties who are doing the work, how to build things, how to put things together, and to hire the frontline worker to get the work done. And other possible source of employer would be the manufacturer. That means the manufacturers of the signaling systems, the train, the track, and all other subsystems. So you have Siemens, Alstom, and all other major manufacturers around the world. And of course, nowadays, China come up with a number of government-owned manufacturers in those major railway subsystems as well. Another party is the SS owner. That means they own they build and own the infrastructures like the track, the train, and the stations. And then they will ask the operators to actually run the system for them. So because the owner have the responsibility to look after the well-being of all the subsystems, that means the train, the infrastructures, they have to undertake the maintenance work and also the SS replacements in long term. So again, engineering of different disciplines will be welcome for those owners. And the last part is academic and research. And well, even though railway is an old industry, but a lot of latest technology are still applicable in railway. So the academic could do the research and provide the education and training, like what you are doing now. You are, because you are now in the university, you go through a boring talk this morning to get through some of the ideas in the railway industry. So that's the major landscape, and that would tell you the diversity of career opportunities you may have in this railway industry. So plenty of opportunities and a wide range of positions available. And just before I go, this slide, I actually find it last slide. Well, I'm sure, well, you still recall I asked the questions whether railway is an old industry. Yes, it is a very old industry of more than 100 or even 200 years old, but all the latest technology are still applicable. So all the niche words like AI, smart cities, cloud computing, IoT, big data, they are all applicable in the latest railway development. So don't be fooled that, well, railway, just put trains on top of the rail and let it run, and it is a simple thing to do, and it is an old industry. But all the latest technology can be applicable in this old industry. And before I go, just one more point. It's basically come from my own experience. Railway is very much an international industry. You may think, well, even in Malaysia, there are plenty of opportunities, but well, sooner or later, you have built enough railways and well, as a railway engineer, so where should I go? But my experience is, well, Hong Kong is an even smaller place. Okay, we have built a lot of railway, but now it's always come to the point of saturations. We can't build anymore. But my experience and experience from some of my colleagues and friends, once you have get good experience in railway, you would be able to work elsewhere in different places. And I have been fortunate enough to be able to work in UK, China, Australia, Malaysia, Singapore, Taiwan, just to help them to build or run railway. So it's very much an international industry. So if you like traveling around, it is perhaps one of the things that you may look into. Okay, right. Dr. Wong, I think I overrun quite a bit. And
Oh, it's okay.
Well, old habit as a lecturer.
Okay, thank you very much, Dr. Marco, for the very interesting talk as well as very informative. I thoroughly enjoy the history part of the railway development.
Right.
I also learned some new terms like a rolling stock, PUA, which stands for the train and also the railway track, as well as a ballast, the little spore stones, and also the system integration. It's very, very informative. Thank you very much.
Yeah.
So let's address some of the questions raised out by our audience.
Right.
So first we have one from Johnny. He is asking, what are the big players in this railway industry in terms of mechanical and electrical application?
Right, and as I said, as far as electrical and mechanical, if you look at the subsystems, it's basically talking about the train and the power supply systems. And the big player, well, A is the manufacturer, because I mean, you won't come up with a train out of nothing. So you have to have a big factory to come up with the train. And of course, there are no manufacturer in Malaysia or in Hong Kong. There are only a few, but they all have offices around the world. I'm sure in Southeast Asia, a lot of major train track manufacturers, they have offices in local. They need local engineers, okay? And they need people who would be able to transfer the technologies from overseas into the local market. I mean, they can't, every time they get a project, they can't just move people from overseas. It's too expensive. And other part is the local consultants and contractor. Well, my experience in the last few years, when we are trying to build the MRT line 1 and line 2, our job as a consultant is to advise the operator what train should they buy. And once they buy the train, we have to test and commission the train that's coming from the manufacturer. Okay, so we have to come up with mechanical engineers and electrical engineers go to the train and inspect all the systems and components and make sure that the manufacturers are actually doing what they are supposed to do in terms of building the train. So there are different angles for the electrical and mechanical engineers to work in the industry.
Thank you, Dr. Mark. There is another question. Does a railway engineer degree provide higher salary than traditional engineering degrees? Very likely from a student.
No, well, I mean, you don't have to worry about it. As I said, around the world, there aren't too many. Actually, there are very, very few degree programs on railway engineering. And most of my friends, and even me included, I'm coming from electrical engineering background. I'm not from a purely railway engineering background. But once you start from one discipline, and if you are able and willing to move and try to learn what other disciplines are doing as far as railway system is concerned, that would be good enough. And that will get you a good starting point as in the career of a railway engineer. So don't worry about where you started. And my advice is engineering is the best starting point. Okay. Now, one of my friends who is now the CEO of MTR, well, you know, a CEO doesn't really just looking after all the technical stuff, but all the management and operations. He's an engineer. Okay, he understands how the whole systems are being put together. So it put him in a very good, advantageous positions to run the whole company. But if you put it the other way, if you started as an accountant, and the routes to get into a railway operator's CEO position would be a bit difficult because you don't understand the technical part of it. So I always say a good starting point as an undergraduate study would be engineering. Well, for those who are not studying engineering in the audience, don't throw eggs at me.
Okay, there is one last question here from Lynn.
Yep.
She says that China is a big country with lots of railway, but
Yep.
in Malaysia, what's the future for those that have chosen to major in this field?
Right. First of all, Malaysia is also a big country. Oh, well, a big country for me, coming from Hong Kong. Well, in one of the last slides that I gave, I can see in the next 10, 15 years, there will be quite a number of new railway system coming along. Okay. Well, of course, when there are new railway lines, there would be new projects. So that means in the next 10 or 15 years, I don't think there would be a shortage of jobs as far as railway engineers are concerned. Okay. Of course, you may argue that after 10, 15 years, then what? And what happens? But don't forget, any railway systems are designed to have a life cycle of more than 50 years. Okay. Remember, London Underground is still running on, but it started 150 years ago. So when you have a system going on, and you still need engineers, mechanical, civil, electrical, to run it. Okay. And after 30 years, 40 years, you need to revamp the whole systems. Then again, it's a new project. Then the engineers, the railway engineer will come along as well. So it's a non-stop cycle of work coming along. So I don't see, well, once a country decided to move ahead in the direction of building more railways, it will not stop. Okay. So the story that I have in Hong Kong is that it started more than 45 years ago when Hong Kong started building the first railway line. But up till now, the operator, the MTR in Hong Kong, keep recruiting new engineers and just to get the system going, just to expand all the lines around in Hong Kong. So there's no limitations to it.
Okay, I think we move on to the last question of the day.
Yeah.
There is one question by Redme, which asks which countries offers good railway engineering program?
Right. I would say UK in Birmingham. They have a very good railway research group, and they have now they have a Birmingham Centers of Railway Research and Education, and they just have a big contract from the British government to. It's called Digitalizations in Railway Center. So it offers a wide range of undergraduate programs on railway engineering. So well, but I quote it because I came from there many years ago. But it is one of the most reputable university offering railway undergraduate programs. Hope it helps.
Okay, thank you very much, Dr. Mark Ho.
Well,
Okay,
thank you very much for all spending all the time listening to me.
Yeah, it was very informative. So before we end this talk today, I also want to take the opportunity to promote that actually for Thai UC students, we actually have an upcoming talk. I think Miss Ng can start to share the slides. Yeah. Okay. So this talk is especially relevant to all the diploma students in engineering in Thai UC. So on 1st July, Wednesday, 11:30 a.m., there'll be a sharing session for the Diploma in Railway Locomotive. So this is a exclusive programs for our Thai UC Diploma in Engineering students. So it'll be shared by Miss Selina, Mr. Joe Chen, and also Miss Anna Song. All right. So this is a collaboration between the Faculty of Engineering and Technology as well as CPE, the Center for Continuing and Professional Education.
Right.
For those who are interested, you can scan the QR code or also log into our website as well. All right. So these are the details of the sharing session. Guangzhou Railway Polytechnic is a full-time higher vocational college in Guangzhou province that cultivates rail transit talents. So this webinar is suitable for anyone who wants to find out more about the following, which is additional certification of a diploma in railway locomotive awarded by Guangzhou, GRP, short form, China. So there will be attracted scholarships and also more employment opportunities. So this is like an added degree in addition to the diploma in engineering provided by Thai UC. Okay. So I also hope that everyone can perhaps search for FOET Thai UC in Facebook and like our FOET Facebook page as well. Okay, so a little more information about this additional diploma in a railway locomotive. It is open for Thai UC first year students. So GRP is established in 2000. Okay, so GRP is the only full-time higher vocational college in Guangzhou province that cultivates these talents. This college has 12 scale on-campus training centers as well as 6 large-scale on-campus training. So more than 99% of graduates has obtained relevant professional qualifications, and the employment rate is very high, over 98%. So to learn more about this, you can communicate, you can send your query to Dr. Teo Cho Yong. So you can get his email address from the faculty website. And if you want more information, you can always email to FOET or COE@TAUC. Okay. So I believe that's all for today. Thank you very much, sincerely, from the bottom of my heart. Thank you for joining us today. Thank you, Dr. Mark Ho.
Well, thank you very much. Okay, thank you, Raymond.
All right. Bye, everyone.
All right, bye-bye.
Thank you.